Find the total blue area in this square. If you would like to have a go first, feel free to pause the video now. The square has side length 4 centimeters. Let the top left corner be A, the top right corner be B, and let P be the point where the two arcs meet. Start with the radius from A. AB is 4 centimeters. Because the same radius reaches P, A to P is also 4 centimeters. The radius continues through another 30 degrees, completing a 90-degree quarter turn. It then returns to P. Now repeat the same construction from B. B to A is 4 centimeters, so B to P is also 4 centimeters. The radius completes the 90-degree quarter turn, then returns to P. We now have AB, AP and BP all equal to 4 centimeters. Therefore, triangle ABP is equilateral. So angle A, angle B and angle P are each 60 degrees. Drop a perpendicular from P to the midpoint M of AB. Let the perpendicular height be h. The midpoint divides the 4 centimeter base into 2 equal parts. AM equals MB, which is 4 divided by 2. So each part is 2 centimeters. Now use right triangle AMP. H squared plus 2 squared equals 4 squared. H squared equals 16 minus 4, which is 12. Therefore, H equals root 12. So H is 2 root 3 centimeters. Now calculate the area of triangle ABP. Triangle area equals 1/2 multiplied by the base, multiplied by the height. Substitute a base of 4 and a height of 2 root 3. 1/2 multiplied by 4 multiplied by 2 root 3 gives 4 root 3 square centimeters. Keep this triangle area for the next calculation. Now calculate sector SA. 60 degrees out of 360 degrees is 1/6 of a full circle. So SA equals 1/6 multiplied by pi multiplied by 4 squared. Therefore, SA equals 8 pi over 3 square centimeters. Keep that result. Now calculate sector SB. It has the same angle and the same radius. So SB also equals 1/6 multiplied by pi multiplied by 4 squared. Therefore, SB equals 8 pi over 3 square centimeters. Keep that result as well. Now add the two 60-degree sectors. Triangle ABP is contained in SA, and it is also contained in SB. So when the two sectors are added, the same triangle is counted twice. The region T must contain that triangle once, not twice. Therefore, subtract one triangle only. This removes the extra copy, while one copy of the triangle remains part of T, so T equals SA plus SB minus the area of triangle ABP. Substituting the stored values, T equals 8 pi over 3 plus 8 pi over 3 minus 4 root 3. Therefore, T equals 16 pi over 3 minus 4 root 3 square centimeters. Keep this value for the quarter circle calculation. Now calculate quarter circle QA. 90 degrees out of 360 degrees is 1/4. So QA equals 1/4 multiplied by pi multiplied by 4 squared. Therefore, QA equals 4 pi square centimeters. Keep this result. Now calculate quarter circle QB. It has the same radius and the same angle. So QB also equals 1/4 multiplied by pi multiplied by 4 squared. Therefore, QB equals 4 pi square centimeters. Keep this result. The left non-blue side region is U1. The right non-blue side region is U2. Together, U1 plus U2 forms U. Now combine QA and QB. The region T is contained inside QA, and the same region T is contained inside QB. So when QA and QB are added, T is included twice, but U contains only the two non-blue side regions, U1 and U2. Therefore, both copies of T must be removed. That is why we subtract 2T, not 1T. So U equals QA plus QB minus 2t. Now substitute the stored values. U equals 4 pi plus 4 pi minus 2 multiplied by the quantity, 16 pi over 3 minus 4 root 3. This becomes 8 pi minus 32 pi over 3 plus 8 root 3. Therefore U equals 8 root 3 minus 8 pi over 3 square centimetres. Keep U for the final subtraction. Now calculate the area of the square. 4 multiplied by 4 equals 16 square centimetres. The total blue area equals the area of the square minus U. So remove U, 1, and U, 2 from the square. The two blue regions remain. Substitute the value of U. The blue area equals 16 minus the quantity, 8 root 3 minus 8 pi over 3. This simplifies to 16 plus 8 pi over 3, minus 8 root 3. Therefore the total blue area is approximately 10.52 square centimetres.